Hi guys, today we are going to look at a question from GATE 2020, paper 1, question number 9. So the question is like you are being given a helical gear with some pressure angle and helix angle, and it is mounted at the mid-span of a shaft, and that is supported between two bearings at the end. The nature of the stress induced in the shaft is, so these are the four options. So the problem is regarding the helical gear or in general gears, and if you want to learn more in depth about gears, please refer to the NPTEL course Machine Design 2 by Professor M.M. Mayuram and Professor K. Gopinath from IIT Madras. So let's proceed with the problem. So what is given in the problem? So you are being given a shaft. Let's say you have a shaft like this, right? So now your gear is somewhere here. So let's say this is my helical gear, and it is being supported at its ends by, let's say, bearings. So you are being given bearings at the end. So I'm having a helical gear. Okay, I'm looking from side view of the previous view. Okay, so now let's say this is my shaft. Let's take this as my shaft. Okay, so now what is happening here is my gear is going to rotate. Okay, so because of this rotation, I'm going to have some forces, that is frictional or the tangential to this thing. So if this is my shaft, so I'm going to have some tangential force. Okay, now because of this rotation itself, what is going to happen is I'm going to also have some radial forces like this, which is Fr. So let me just take it towards us. Let's say Fr. Okay, and since it is a very highly dynamic system, so this is my gear, this is my rod, which is fixed at the end. So it is going to have some axial forces also. So here we do have axial force. How do we have axial force here? So if you look at the question, you had that it's a helical gear, right? So your gear will be having teeth with some helix angle, right? So let me just take one particular teeth. Okay, so if you look at this point, okay, so when this particular point or this point where it actually engages with another gear, so let's consider this as the same point. So what happens is you have two gears like this. Okay, so the forces are going to be normal to this particular angle. That is how the gear is. So what's happening? So let me draw here once again. What's happening here is you have some force which is being transmitted normally, right? So this force can be resolved in two ways, right? So you can see this is your axial force, because your total gear is going to be like this. Yeah, so this is again contributing to your tangential force. Okay, so you can see that there is an axial force because of this particular engagement with another gear. So that is how you get an axial force here. So this particular axial force will be acting on the rod as well, so when it is in engagement. Okay, so now let's see, you're having ft, fr, f axial, okay, tangential, radial, axial. Let's take one by one. So now if I'm going to have a rod like this, okay, let's say it's a 3D view. So now if I am going to have some force like this, which is basically tangential force, it's going to do what? It's going to create torsion, right? So due to this torsion, what we are going to get is some torsional shear stress, right? We're going to get on this rod if we have some force like this. Now same way we are going, now let's take another view. We are seeing straight, and this is supported at the ends because of bearings, right? So now you have some radial force since because of the gear, right? It can be like this, it can be like this also. At different instants it can be there. So at some particular instant your rod is going to face, let's say, this way, and it becomes like a simply supported beam, right? So what are you going to see? It is going to undergo some bending, right? So now if you take some different configuration, it's going to bend in another plane. So because of your FR, it's going to have bending in different planes. Bending stress. Okay. Now third is axial. So if you're going to have some axial force on this, you're going to get axial stress. Right. So what all we got here? This, okay, let me just use this again. So we are having first, because of Ft you are going to have torsional stress, shear stress basically. Then Fr you are having bending stress. At multiple planes. And because of Fa you are going to have axial stress, right? Now let's check out the answer. Let's check out the question. So you can see it's not bending in two plane shear stress, that's not the answer. B, bending in two planes axial loading shear stress due to 2. So B is the answer. Rest are all incomplete answers. So here why D is not the answer? It says only bending in one plane, which is not correct. So your final answer is B. So this was something very conceptual, which links both, simply supported beams, because here the load is because of the gear, as you can see. So it is connecting both the gear problem and the simply supported beams problem basically. So this might be one of the easiest question, and if you don't know the concept, you won't be able to answer this. So always focus on learning the concept. Okay, I hope you all understood the problem. So thank you.